how we can put the pieces together. It's a very often overlooked part of ETL pipeline. So I'm really excited to be able to talk about this and kind of get people going who don't really know where to start, or maybe you do know where to start and you want to have a good way to add things in, and it just maybe a new way to look at the problem. So in this talk, we're going to be looking at the tooling, the scheduling, dependencies, and alerting. Those are going to be our kind of 4 big chunks that we're going to look at before we go into a demo. So our tooling is kind of the how, what in Airflow do you actually use to do data quality checks? The scheduling, of course, the when. Airflow is an orchestrator. Scheduling is a primary concern. We're going to be focused more about what does it look like when you want to run your tests in a DAG versus as its own DAG. The dependencies are kind of the where these data quality tasks actually take place. And this is tied deeply into scheduling, but is differentiated enough that we'll give it its own little section. But again, we're going to focus on what does it mean for data quality to operate inside a DAG versus as a DAG, and what does that mean for the upstream and downstream aspects of the pipeline and the data ecosystem. And finally, we're going to talk a bit about alerting, which is the who. And that's, of course, your stakeholders, which are going to be engineers, analysts, researchers, executives, anyone who cares about data. And they're going to, they should be an integral part of the data quality process, because a lot of times it's the stakeholders of the data that know what the data should look like better than the data engineers do. So let's dive into each one just a little bit more. So we're going to look, what do these things actually really mean? So for tooling, we care about things that are reliable, simple, and manageable, because that's what's going to allow us to iterate really well in a clean, easy way. The big takeaway here is someone less technical than a data engineer should be able to write data quality tests. That could be a data analyst, that could be a researcher. We want to make the process of doing data quality as democratized as possible. And that's going to allow more people to do it, which means that you're going to have more coverage over the things that you really need covered. The scheduling, we're going to look at frequency in DAG and as a DAG. We're going to get to what that means in just a little bit. Big takeaway is data quality tests should run on existing pipeline schedules. We shouldn't have to rethink the whole data ecosystem at your organization just to add data quality. Dependencies, we got our upstream tasks, downstream tasks, and then again, in DAG versus as a DAG. Our big takeaway, data quality should block and be blocked as needed. When there's bad data, it shouldn't get to a data warehouse where it can break dashboards or ruin machine learning models. So we're going to take a look at what does it mean to put data quality in the right context so that it's preventing these outages. And finally, alerting. We care about our stakeholders. We care about what to do when tasks fail. And we care about the different ways we can use operators to alert our stakeholders. Big takeaway is when tests fail, the right people need to know right away. This can't be something where we fail and we find out about it a week later. The whole point of data quality is that we know when things are failing and we know how to fix them right away. Sorry. I've gotten very dry here in New York in the winter. My throat hasn't quite caught up. So let's jump right into the tooling. What does it mean? How does it actually work? So in the demo, we're going to be using the SQL Check Operators and taking a look at them. The reason we're focusing on the SQL Check Operators is because they come standard with OSS Airflow. So no extra providers that you need to download. They just already exist. They work out of the box. Super easy to write queries. There's already several different kinds of checks that you can do, some of which you don't even need to write queries for. And again, because all you have to do is write SQL queries for it, people other than data engineers can write tests even if they can't write DAGs. So they can be a part of the process. Data analysts can write SQL queries, and the data engineers can take those queries and turn them into tasks very easily. And then, of course, when new checks are needed, you can just add existing queries and create new tasks super easily. So it's a very quick iteration process. There is a drawback that will go more deep more deeply into during the demo with the check operators right now, but it's one that we're actually working on fixing at Astronomer right now to make sure that these check operators are actually looking at your whole table and not just single rows. But we have a workaround for that right now, which we'll demonstrate in the demo later. Finally, just want to give a quick shout out to Great Expectations. They've been a great partner with us, and they have a really great offering where if you already have come a long way with your data quality and want a really robust tool that kind of already exists in a more mature state, they're a great org to check out to do data quality on your tables.
Benji, we should probably do a webinar with Great Expectations in the coming couple of months, right? now that you mentioned it. Yeah. So maybe we'll add that to the coming soon list.
Yes, please. They'd be a great one, especially when we're talking about iteration and you already have everything that your SQL check operators can do. They're a great next step. They also have profilers, which are super helpful, and you can check out all of that on their website. So let's take a quick look at, what do these operators actually look like? We see here on the left, we have the value check operator, interval check operator, and threshold check operator. During the demo, we're going to see these again and go a little bit deeper into them. But it's nice to just take a quick look now and see, how is the SQL actually a part of this? So like the value check operator here, we see that we have a really simple select count star from table. And we have a pass value. So we know exactly what we should expect from that table. We know that if we get 0 rows returned from this query, something horrible went wrong, and we can get alerted about that. On the right here, the astute observer will notice that it says Snowflake check operator. We can go into that more in the demo, or if people have questions during the Q&A. But the Snowflake check operator is the same as the SQL check operator. It just works with the Snowflake backend. So here we see that the SQL is actually going to a file and that we have a templated search path to that file. So we can keep our tasks really, really clean. And this actually makes it even easier for analysts to write SQL queries, because they literally just have to write SQL code in a file, and that file can be added to your repository. And then it just needs to be referenced by data engineers who are putting tasks together. So in this way, you can really actually have a collaborative effort on data quality. And you can see there's the row quality check and then the date check below it. We'll go into the demo, but basically you can split these checks out, and we can do templating with the check operator as well. And that's going to just make it even more iterable and more clean to write these tests. And we can see here, this is kind of the difference from those two check operators on the right side. This is what the SQL in the SQL files actually looks like. On the top, we see that, all the SQL is just a bunch of case statements. It's all in one file together. On the bottom, we're actually just spot checking one row, because we can't check the entire table unless we have a task for every single row in the table. And that's just not a scalable solution for us. So this is not the recommended way to do it, but it's good to see what the not recommended way looks like. So when we look at the SQL file below, we see that it's way simpler. It's just a few lines. What we're doing is we're actually checking an aggregate now with the minimum function. And then we have a subquery where we have our case statement there. And then we can just pass in the check name and the check statements as arguments from our task. And we still have this case when, our check statement will be like the drop off date time greater than pickup date time, then 1 else 0. So that when this is passed into the min function, we know that if the task succeeds, then 1 is our minimum value. Therefore, every single row in the table passed. But if the minimum is 0, then we know that at least 1 row failed. And then we can take this statement from the log output, which we'll see during the demo, and we can just copy and paste that and modify a little bit in Snowflake or BigQuery or whatever it is we're using. And we can identify the actual rows that are failing. And so we get our observability from there really cleanly. So let's move on to scheduling. as I said before, we're going to focus on what does it mean for data quality to be in DAG versus as a DAG. In a DAG, we're going to be probably more worried about our critical pipelines, data that absolutely cannot get to the data warehouse tainted. And this is going to be mostly looking at things on data set and table level, pipelines that probably run mid to high frequency, so like daily or several times a day, or maybe even several times an hour. In some cases that are trying to mimic streaming, maybe even every minute. So the as a DAG is just a little different. We have our post hoc pattern, and we can just run, because the data quality pipelines are running on their own, we can run them whenever we want. And so this gives us a little more flexibility in terms of doing things like aggregate table metrics that maybe we want to do daily, maybe some we want to do weekly. And so we can split these things out and just make sure that they're running at kind of our leisure and doing the aggregates when we care about those aggregates. Next, we're just going to take a quick look at, what does that actually mean? What does it look like when the scheduling is inside the DAG? And here we see we have our ETL pipeline here, and we have our data quality checks towards the end after this converge to. We have our 4 data quality checks here, and then they merge on a drop table. If we were going to do this in production and not just a demo DAG, we might want to have them merge on another load table task. And this load table would be loading the data from the staging table that the data would be quality checked in to the production table or the dev table, where we don't have to worry about bad data getting there. And then the drop table would happen after and we drop the staging table. So that's what our scheduling in a DAG could look like.
Benji, I could see this being really helpful right before a BI refresh, right? Like if I'm about to trigger a Tableau refresh through Airflow, I'd want to check the data I'm about to refresh to make sure it's correct, right?
Absolutely, yeah. A great real world case there. So then we have as a DAG, which is just our data quality checks. Super simple. We can, again, run them whenever we want. We don't have to worry about dropping tables. We don't have to worry about the other aspects of an ETL or ELT pipeline, which means we also don't have to worry about these things potentially messing up an existing pipeline. So now we'll talk a little bit about our dependencies. Again, super related to scheduling, and we're going to keep this idea of in DAG versus as a DAG in mind. So what does it mean for data quality dependencies when you're doing data quality in a DAG? Well, your upstream is going to be probably the extract or load or transform, or potentially all of the above transfer parts of the ELT pipeline. And that upstream can include APIs, daily deliveries generated from your platform, anywhere that the data is coming in or getting moved around. And the important thing to consider here with your upstream is, something like an API, that API can change, and they might not tell you that it's going to change. So having data quality downstream from that will be able to catch those API changes and make sure that you're not loading change data or the wrong schema into your downstream data warehouses and data lakes, because that could just obviously be bad news, broken dashboards, ML models that aren't working anymore, all sorts of issues. As a DAG, similar but different. Your upstream is now more DAG related, so it's going to be your whole ETL and ELT pipelines. This data might already, is already going to be dumping into a data warehouse or data lake, and then you're going to have your data quality DAGs that are triggered from there. The important thing to remember here is that it's not just upstream tasks that are going to trigger the data quality tasks. It's going to be all these upstream DAGs. So if you are doing it data quality DAG, you may want to have it triggered when all of those upstream DAGs are actually completed. And there are operators to do that in Airflow, where you can actually wait for other DAGs to complete. And once they're all complete, then we can trigger the data quality DAG to run, which again, going back to our scheduling, means that we may not want to actually specifically schedule this kind of data quality DAG. It may not make sense to run it at the top of the top of the hour every hour. It may not make sense to run it at a specific time every day, because we're waiting for all of these stochastic upstream DAGs to complete. So we can mess around with the scheduling for our DAGs, and we can just say that it doesn't have a schedule and it just waits to be triggered. And then finally, we can do the same thing with our data quality DAGs with respect to downstream DAGs. We can make sure that all of our data quality DAGs finish running and that those are the ones that trigger your updates to your dashboards or trigger your machine learning algorithms to run.
So it looks like as far as if I'm trying to do dependencies as a DAG, it's a little easier to rely on upstream ETL pipelines rather than upstream APIs, right? You can't really control what's in an upstream API, but as a factor of control, right, you can probably control your ETL pipelines a little easier.
Yeah, absolutely. Just gives you a little more awareness into what's going on. So let's talk a little bit about alerting. We have our who, when, and how, all pretty straightforward. It's just good to keep in mind. You know, our who, obviously, engineers are always going to be stakeholders. They're the ones writing the DAGs, but you want to make sure that whoever else is involved, you know, whoever is going to be alerted probably should be a part of the process from the beginning. They should understand a bit about how these data quality tasks are put together, how they're scheduled, what the dependencies are, and just make sure that the data quality story is understood by these stakeholders who will be alerted, so they have a better understanding of, you know, why is it important to bother them with a PagerDuty in the first place. They should also probably be a part of actually creating the data quality checks as well, because, you know, they're close to the data, they know what should be right and what should be wrong. At least we would hope so. The when, there's a lot of different times we can alert. Airflow is very flexible on things like pipeline failures versus just certain tasks failing. And we can make sure that when tasks fail, they can alert right away. We can also just see when the entire pipeline fails, we can send alerts as well. Finally, the how, email, Slack, and PagerDuty. Obviously, a lot of orgs are using all of these or some subset of them. Emailing on pipeline failures is kind of built into DAGs, super easy to do, highly recommended, just as a fail-safe. Using the Slack or PagerDuty operators, you can, you know, send messages to specific people who are on call or just to Slack channels. And so then you can make sure that, you know, all the right people are notified as soon as these failures happen. And, you know, we make sure that the whole data ecosystem is kind of accounted for in this way. Great. And now we're actually going to take a look at our demo. That's all the slide content for you. So we'll get to the real interesting stuff now. So we're going to take a look first at some of the code and what that DAG looks like in code. And we'll take a little deeper look into the operators and look at some of the SQL. And then I'll actually just show you, you know, what does the DAG look like, how it's running. And we're going to take a look at what the log output's like on success and failures. So without further ado, the screen sharing, we gotta.
While you're pulling it up, Benji, just as a reminder, we will send out these code samples afterwards, so don't feel the need to rush screenshots of Benji's IDE here.
So we can see here, you know, we have lots of imports here, a little bit of top level code just to get our constants. But here's the real, you know, meat and bones. Here, we're just setting up our DAG. You'll notice that the schedule interval is none here. This is just a demo. But this is where we would choose our scheduling. We're using Snowflake as a backend, so we want to make sure that we have all of these different pieces of the puzzle here to make sure that our Snowflake connection works for all of these check operators. And then we have our template search path. This is kind of a really important piece because this is where all of our SQL files are going to live. And so knowing where to put these SQL files is important when you're doing team collaboration on creating these checks, because this is actually where we'll see later the operators will look for those files to run them. So here we have a few tasks that are just adding upload dates and deleting the upload dates. We don't have to go too much into them, but basically the data set that we're using doesn't come with upload dates as part of the columns. So we need those for one of the operators that we'll see later, and we just add them in and remove them as part of the demo. But we know that, real life data, we're going to have things that are going to, have upload at, created at, all sorts of metadata like that. So we're just adding that in. So the real relevant stuff here, Snowflake table creation. We're just using the Snowflake operator. Our SQL is a super easy one-liner in the SQL file. I'm not even going to really take a look at it because it's pretty straightforward, and you can look at it when you get the code sent out. You do need a staging table for this example. I created one manually, so I commented out the operator here, but you feel free to use the operator here or just create your own manual staging table. And then of course we delete the table because it's a demo and we want to do cleanup in a production environment. This could just be deleting our staging table. So now the value checks, what we're here for, what we care about. So the Snowflake value check operator is the same as the SQL value check operator. As I said before, all the Snowflake operators that you're going to see here are the same as the SQL ones, just made for the Snowflake backend. Airflow 2.3, we won't need this anymore. All the SQL check operators are going to have support for these backends natively, but it's not released yet. We can see here, we have our one-liner of SQL again that we saw earlier, just a simple select count star from. This is a great test for almost any table that's going to be filled at any regular interval, because you want to make sure that, if you expect data to be added to a table every single day, then there better actually be data added every single day. And so this is a super easy check to make sure that that's actually happening, because that's one of the simplest ways to check to see, if something like that is going wrong, there's probably something really going wrong that you need to take a look at. In this case, with the example data, we're uploading 2 days worth of data at once. We know that each file has 10,000 rows, so we know that the pass value is exactly 20,000. This operator also actually has they don't call it threshold. It's a tolerance. And this tolerance is a number between 0 and 1. And that's the percent tolerance that the pass value can be within. So if we gave it a tolerance of like 1%, then that means that we would care about, what is that? Viraj, check my math, plus or minus 20 rows.
You're asking me to check math on the fly here. That's my worst nightmare.
Okay. 1% of 20,000 is 200. So it'd be plus or minus 200 rows for the pass value if we said we wanted a tolerance of 0.01. So, that's just one extra little feature that we have in the value check operator. And we can use this for any sort of counting, any sort of count that we're doing, any numeric that we have in our table. Then we have our interval check. So this is the interval check is what we needed to add this upload date for. The interval check is really interesting because it allows you to check a reference day against the current day. So we have our days back equal to 1 here. So we're going to check yesterday's data or today's data against yesterday's data. The default, I believe, is a week back. And we have here our date filter column. This is the column that it's going to look for to make sure that it's using the correct dates. And then we have our metrics threshold. So this is a dictionary, and it's going to be pairs of what the metric is that you're looking for and the threshold for that specific metric. And then what this operator is going to do is it's actually going to template out a whole SQL query for you, including a formula. And there's 2 different formulas you can check the docs in. And it's going to run each of these metrics. That's the key for the metric through that formula. And it's going to check it against the threshold that you give as the value here. And so you can have a whole list of, we're just looking at average trip distance. And that's basically because we know this is taxi cab data. which I don't think I mentioned before. So we know, if we're thinking about a taxi system, I don't work in the taxi industry, but I can take a guess that, we would want to know that the average trip distance on a given day is not wildly different from the average trip distance of the day before. We would assume that, probably day to day for most days, the trip distance is going to be about the same. And we might want to use that to take a look at, how might holidays be different than the average day, or especially know if, the average trip distance is much, much shorter on a specific day. We might want to figure out why that is as well. I have it set to a very robust 1.5 here because, again, I'm not actually a taxi professional. I don't know what this number should be, but it just seemed like a good one for our demo example, and it passed the test. And that's the wrong way to write data quality tests, but for a demo, it is acceptable. We have our threshold check here. Again, another super simple check operator. We give it a SQL query. We have our one-liner right here. And we're just going to look at our max passenger count. Again, not a taxi professional, but I would assume that there needs to be somebody in the taxi for there to be a trip. And we don't want more people in the taxi than there are a number of seats in our biggest cab.
Well, Benji, you bring up a bit of good point as going through these examples, kind of highlighting why exactly it can't just be data engineers writing checks. All of your assumptions are all business assumptions. They're not really data assumptions.
Right. And I'm not a taxi businessman, so I couldn't tell you if those assumptions are good or bad. I can just tell you that most of these tests pass, and we'll take a look at why the ones that don't pass. But I think, of all the assumptions we can make, this is probably the safest one besides, the data engineering assumption of we know how many rows, because it's a static example. But even that one, if we were using live data as an engineer, unless I was looking at dashboards that analysts had made, I probably wouldn't know what that number should be or what that tolerance should be. So we have our min and max threshold here, 1 and 8. That again comes from the data, kind of working backwards, but we can pretend that a business analyst, knows the max number of seats in our biggest cab. So finally, we're going to look at just the plain old check operators. And we're going to look at kind of the recommended and not recommended way to do things real quick. So again, we're going to start with the not recommended way here. We see that it just exists as a single task. We're referencing the single file, and we set our parameters that gets passed in, so it checks the correct table. It looks easy. It looks super simple. If we want to do spot checks on, say, 10 different rows, we could add a loop here and another task group, and we could just, run this task 10 times. Not recommended, as we'll see, because spot checks are not going to give us all the coverage that we want. And again, if you have it all your SQL checks in just one file, that file can get monstrous pretty quickly, and it's going to make maintaining it really a pain. And when things are hard to maintain, they stop getting maintained. And now you've completely undermined the whole reason to do data quality. So we're going to look at what does it mean to template this instead. So we're going to break out all of the different checks in this one SQL file into their own files. And what does that look like in terms of a task? Well, our task gets a little more complicated, but not too terribly more complicated. We still reference our SQL file here, but now we're referencing a template file. And our parameters get a little bit bigger. We give it the name of the check that we want to pass in, the actual statement, and then again, we're giving it the table that we want. If we know that we're always checking the same table, then we don't need this parameter. We can probably just put it in the SQL file. So the two really important parameters here are the check name and the check statement. Again, these can be written by analysts, and then the engineer just has to copy and paste them into this check operator. And when we want to make a new check, all we have to do really is copy and paste, and then we change the name here, we change the task ID, we change the check name, and we change the check statement, and we've got a new task, and we've got another data quality check. It's really that simple. We don't have to change any other SQL. But we're going to get rid of that one for now because the Airflow scheduler really doesn't like it when you have two tasks named the same thing. So we see here we have our date check, Our whole statement is just drop off time is greater than pickup time. That seems like a given, super simple. Our passenger count check, we want to make sure that there's, we see here greater than or equal to 0 passengers. This is mostly to make sure that this check passes, because in the example data, there is a day that purposefully has bad data to reflect test failures. So we want to just see this test pass. If we want to see this test fail at certain times too, we can just say greater than 0. Our trip distance check, we want to make sure that the trip actually went somewhere and that it didn't go too far. Again, this 100 number should come from a business analyst or somebody who knows the business use case. And then finally, we have our fare check. And we can see here that even with a very simple structure for our SQL check, we can actually still have a pretty complex check statement here where we're doing a pretty big calculation here with some rounding. And we're actually adding a case in here. So we can keep adding cases as well and check as many cases as we want. And we're doing a lot of rounding here just to kind of make some of the math work out. Because again, this data was set up to fail in certain cases, and we want some examples where this passes. So, but it does also double as a good example of, we can make this very complicated if we want to. It is resilient to simple and complex statements. And then we can see here in our actual template file, it's just what we looked at before, where we have our select min as our aggregate. And then we have our subclause here with our case when check statement. And so because these are templated, our check statement from before is just going to get pasted right in here. So if we have a case when, as long as it ends with the assumption of, then 1 else 0, we can add whatever we want that's valid SQL to this check statement, and we're good to go. And then if we have our parameter as a table here, and we want to check multiple tables in this way, we don't have to create a new template for every single table. It really is just that reusable. And then again, this is our more complicated one. We can see all of the same SQL logic just in one place, but we're only looking at one row that's randomly selected. And we're going to see why this is not always a great idea. And then finally, we just have our load to Snowflake here. What we're doing in the pipeline, as you'll see, is we're going to be loading data, local files to S3. And then we're going to be moving those files from S3 to Snowflake in using a staging table. And then finally down here, we have a little for loop because we have 2 tasks that we're doing simultaneously. So we're going to make use of dynamic task generation here. And that's our local file system to S3. We're going to upload both those files at the same time. And we're going to make sure that we actually add that upload date and then remove that upload date metadata from our file columns. So that's it. That's the whole DAG. We can see here we just order all of the tasks. It's important to note actually with this chain. Chain is a nice abstraction if you have a relatively simple DAG, but the big thing to note is that this this chain is at the same indentation level where it's within the for loop, because we want to make sure that each of these dates are added as their own tasks, and so we have to do that within the for loop. So that's just one little thing to note. With that said, let's go back to the web browser here, and we're going to take a look at what this DAG actually looks like. Stop presenting for a second, and we have it up here. As I said before, our DAG is not scheduled, and we can see in the upper right corner, schedule is none. So we'll just manually trigger it real quick. Our CRF token is expired. Oh no, I think I have to reload our local host here. Raj, you have questions, comments in the meantime while I reboot my local host real quick?
Yeah, go for it. I can kind of hold them there.
Okay.
I also just found out that I think there is a setting we tweaked on the chat that isn't working. So you can only see your own messages, but my message is going to everyone. So first off, if anyone's sorry about that, if you're getting random messages from me that we're answering questions that weren't yours, we'll definitely fix it for the next one. The Q&A section is also great for questions if anyone wants to ask them there. Well, Benji's getting his Docker cache reset. I guess one thing to throw in the chat here, and once again, I'm not sure if everyone can see it or only a few folks can see it, is do you want to just put in if you're using data quality checks in your current ETL pipelines? And if you aren't, why not? Is it just you don't think you need them? Do you think that, is it something you want to get to but just haven't had time for yet? That would be really helpful. I see a question in the chat. Incremental ETL pipelines schedule once per hour using Airflow. Copy source.
Okay. So we can see here that I logged in. I have a whole example repository that's public on GitHub of a whole bunch of different data quality DAGs with different backends and different tools that you can use. We're going to be looking at the Taxi Snowflake EL DAG down here. I call it an EL DAG because it doesn't actually do any transformations. I guess technically you could consider adding the upload date a transformation, but it's not actually transforming data. We're just adding a column. So, for me as a judgment call, I'm going to not consider that a relevant transformation the way we would really think about that in an ELT pipeline. So we're just extracting and loading data and doing a data quality check on it. And that's perfectly valid use case as well. So now we're going to trigger the DAG. We can see that it's actually been triggered. We have a new run that's going on here, and let's catch the graph view before it finishes. So we can see we're uploading data right now, creating the table, loading the Snowflake. And then we're going to start doing all of our data quality checks. These are going to happen one at a time because it's a sequential executor because I'm just running locally. But we can see some of the checks failed. Even though some of the checks failed, we actually still did our delete Snowflake table and delete our upload dates when we did our cleanup. This is because delete Snowflake table is using the all done trigger rule instead of the all success trigger rule. And so that just means that, as long as all of the tasks upstream have completed, we're going to continue with the rest of the DAG. And so that's a nice thing to know doing data quality. Again, going back to our dependencies, if our downstream dependencies can handle certain task failures, then we may care more about using that all done rather than all success. But if we care that our downstream dependencies really do get blocked by task failures, then we want to use that all success. And there's certain tasks that might run like a Slack message, right? That runs on all failure, or maybe we only care about running a PagerDuty notification if all of the data quality tasks fail. So with that said, let's look a little bit at the logs of why some of these passed, why some of these failed. Here in the row quality checks, we have our date check, our fare check, our passenger count check, and on the bottom, the trip distance check. Those are the four that we broke out individually from the big single query. And that row quality check is the one that was all of the queries in one that we were just spot checking a single row. So we see that even though 3 of these failed, our row quality check aggregate one still succeeded. And we can take a look why in the log here. And we see, this is the query that we ran, and it has all the templates put in there now. And we see here, this is the record that was returned. This is our single row returned from the query. We see that we got a 2, a date time, a 1111. So this particular row, all the data was good. So we know that there is good data that exists for all of these checks, but we know looking back here that date check, fare check, passenger count check, these were aggregates on the table where if at least one row fails, the whole task is going to fail. So let's look at what that is, what that's looking like in the log here. And so we see we have our select min date check and our clause here, exactly what we'd expect. Drop off date time is greater than pickup date time. And we see here at the bottom results 0. We know that the test failed. And we know that it was this test that failed. And we know the exact SQL query here that was run that created that failure. So we can copy and paste this directly into a Snowflake worksheet. And we can run the query, we can modify it, we can figure out, what is going on here? What are the rows? What are the number of rows? What are the specific rows that are failing this test? And this is not something that would be as easily observable the other way. So if we go back to a row quality check, first off, we wouldn't even think anything is wrong. But if we're looking at, what is this record that was returned here, and our 1111 is a little bit confusing, even with just 4 checks, because we have to go, okay, well, this one corresponds to this check, and then the second one corresponds to second check. And so we have to manually go through these. If there were 10 or 20 or 100 different checks, this would be, more and more impossible to actually figure out what is going on if a single, even just a single test goes wrong. And even if we were to add the names of the checks in here, it would still be difficult, as we'd have to scroll and scroll and scroll to figure out what's going on here. And this is a lot more clean because we know clicking into the task exactly what we're looking at. And that's it. That's the whole demo. So we can go to
Awesome. Benji, that was incredible. We had a lot of great questions come up while you were switching over to your switching between hosts. I guess one question that has come up that I'd love your thoughts on is, have you used AWS Deque before?
EQ.
I think that's the right way to pronounce it. DEEQU.
No, I have not used it for. Oh, and are we okay to stop sharing?
Yep. Yeah. That came up as a request for some guidance around. It's used by AWS to do essentially data quality on large data sets. I think I've run into a few customers using it too. Yeah. So it would be great to look into that in the future.
Yeah, sounds like a blog post or a future webinar.
Yeah. And then it sounds like Emily is interested in how others are using Great Expectations with Airflow. She's currently running into issues.
Yeah, so I was actually just talking to that. I was at their community meeting earlier today and been talking to them a lot. So they're actually gearing up for their V3 API release. And as part of that, well, I think part of their V3 is released already, but there's a lot going on there, especially with the Airflow operator. The Airflow operator actually doesn't currently support Great Expectations V3 API, and I've been working with them and some other people who are very active users of Great Expectations, and especially with Airflow, on making sure that the operator is upgraded to use the V3 API. So that's coming hopefully in the next few weeks. It's definitely a big concern for a lot of people. So, when that hits, we'll definitely make some announcements about it, and, be ready to give some guidance on how that works, and, be updating the example DAGs in this public repository I was talking about with examples of using that operator with the V3 API.
Yeah, I'm really excited for that. That'll be maybe that'll be the topic of our Great Expectations webinar.
Also, if you aren't a part of their Slack, they have a public Slack group, and they have an Airflow channel on there, and they're really responsive with questions. Anyone else?
Awesome. So one other question that Monique had, Benji, and this is a use case I think we need a full other session to go into, is thinking about data quality in terms of database replication. So we need to make sure your AppDB and your Analytics DB are in sync. Yeah, that's such a loaded question. I feel like we can't even answer it in a short way.
Yeah. So I think, that's something you could do with SQL queries. If you really want to spend the time and be painstaking about it, but that is kind of a more advanced use case. And correct me if I'm wrong, but I think we actually, again, bringing them up, another shout out. I think Great Expectations, that was one of their first use cases that they kind of built their tooling around, was checking like parity between different databases. So definitely worth looking into that as well.
For sure. Let's see here. Benji, how are folks approaching checks over a window of time, say 2 weeks or something?
So the interval check operator could be used for something like that. It may have to be modified a bit. That's the only like temporal check to use there. Again, that's a little more advanced use case. You might have to write a custom SQL query to do windowing. Definitely not impossible, but a little more complicated. I don't see why you couldn't do that with a SQL query. But there are, I would look into, Great Expectations, or, even DBT might be able to do something like that as well.
Michael, there's no dashboards for the check status in Airflow UI right now. That is correct. Maybe down the road, that could be something cool as Airflow gets more data aware, keeping some of that visibility in the Airflow UI. But as of right now, there are not. Question from Dimitri, Benji. Any advice about using Airflow and DBT together? We're currently using DBT for ELT together with our storage and Google Cloud Platform. DBT has some test functionality. The problem is DBT overwrites store failures tables every time, and we can't use it for any historic stuff. Wondering if there's a way to rope this together into Airflow.
There are ways to run DBT with Airflow, and on the Astronomer Guides website, we actually have a few different guides breaking out how to do it in different ways. What you mentioned about overwrites, I'm not sure if Airflow necessarily solves that problem, because Airflow is just scheduling what DBT is already doing. It's not actually able to really like kind of reroute what DBT is doing. But there are ways to kind of break down DBT tasks and schedule them individually. So there may be a way to do it. It might be a little hacky, but you can certainly do all your scheduling of DBT with Airflow.
Awesome. So I think those are all the questions. Thank you everyone so much for joining. We'll be sending over the code samples afterwards. But until then, please look out for a future, I'm sorry, we're a little lost today. So let's try that once more. Thanks everyone for joining. Really appreciate your time. We'll be sending out all the code samples as well as a recap of the webinar in the next couple of days. And until then, please be on the lookout for the next webinar in 2 weeks. And we will tell you the topic shortly. But until then, thanks so much for your time, and we'll talk to you soon.
Yep. Thanks, everyone.